Friends, we were discussing about the absolute viscosity. Okay, so absolute viscosity, or it is known as dynamic viscosity. Why dynamic viscosity? That I will discuss in this lecture. In last class also we have defined basic definition of viscosity and from the Newton's law of viscosity also. Now tau is equal to mu du by dy. Am I right? Du by dy. This is Newton's law of viscosity. So mu is nothing but tau by du by dy. Now I am going to discuss the unit. Very important concept in fluid mechanics. Not only in this first unit, throughout all the units you have to study this viscosity. In every numerical there will be viscosity, and unit of viscosity will not give you straight away. They will give you some other units. We have to convert those units in SI units, then only we can apply in this equation. Okay, that is very important concept. See here, now this tau is nothing but Newton per meter square shear stress. So stress is force per unit area, and this is velocity gradient. So du by dy, that is velocity is meter per second and per unit distance is meter. So it is nothing but per second. Okay, so it is Newton per meter square second. Okay, so it is also called Pascal, Newton per meter square, Pascal. Okay, second. See, du by dy is, see here, du by dy is not second, 1 by second actually. This is 1 by second. Okay, so 1 by second. So Newton per meter square, and that will second will go in upward. So this way. Okay, so Pascal second. Why it is called? This Newton is the force unit. That's why it is called dynamic coefficient. Dynamic coefficient, because force analysis, dynamics means force analysis will be there. So Newton is nothing but here force unit. Since the force unit is involved here, that's why it is called dynamic viscosity. Okay, dynamic coefficient of viscosity. Now if we convert this one, Newton is nothing but kg meter per second square. Am I right? Into second by per meter square. See here, so this meter and this meter will get cancelled. This second and this second will get cancelled. So kg by meter per second. Okay, kg per meter per second. Kg per meter per second is also known as unit of absolute viscosity. Remember this units, this is SI units. Okay, so mu is tau du by dy. Tau is Newton per meter square. See here, Newton per meter square, and it is 1 by second. So Newton per meter square, Newton per meter cube, sorry, and by S by 1. So it is Newton per meter square second. So it is Pascal Newton second, and it is Pascal second. Okay, and if we convert this one, Newton is nothing but kg meter per second square. That is force. F is equal to mass into acceleration. Mass is 1 kg and acceleration is 1 meter per second square. The force required is called 1 Newton. Okay, so 1 Newton is nothing but kg meter per second square into second by meter square. So kg per second per meter. So what are the units of mu? Units of mu is Newton second per meter square or Pascal second, easy to remember, or we can call it as kg per meter per second also. All are one and the same. Okay, now they will not give you the unit of absolute viscosity in this unit like Newton second per meter square. They will not give you. That is How they will give you? They will give you in CGS system. So they will give you Poise. Poise is, what is Poise? Let us see. Now we must know how to convert this into Poise and what is Poise first of all. See here, this one, mu is equal to Newton second per meter square. Okay, that is in SI units. SI units. Now I am going to convert Poise into this one, Newton second per meter square. That is very, very important concept, and you must know how to convert this one. They will give you sometimes in Pascal second, but most of the cases they will give you in Poise. So what is Poise? See, SI units, if we talk about CGS system, CGS units, then it will be dyne Newton instead of Newton, that will be dyne, and that is percent centimeter square. See here, in CGS system, force will become dyne, second will remain the same, and since centimeter, gram and centimeter square, okay, this is known as Poise. This is known as Poise. This is known as Poiseli actually. This Poiseli was the scientist, okay, so named after scientist Poiseli, so it is Poise. Now, how to convert? This is what is Poise? Remember, CGS system, they will always give you Poise. So Poise is nothing but the unit of mu, absolute viscosity. Okay. Now how to convert? Let us see here. 1 Newton second per meter square. This is your standard unit in SI units. Remember, this is the standard unit. Okay. In applying the formula, we must know this one. We have to apply in this form. 1 Newton second per meter square. And now we have to convert this one. Dyne also. So 1 Newton is equal to 10 to the power 5 dyne. It is 1 Newton is equal to 10 to the power 5 dyne. That is the conversion, CGS system. Dyne is the force unit, okay, in CGS system. That means how it is coming? Force is equal to mass into acceleration, okay. Mass is in gram, okay. Acceleration is 1 centimeter per second square. See, gram by kg, okay, that is 10 to the power 3. Centimeter means 10 to the power 2. So it will be 10 to the power 5. Okay. So this force, gram into per second is known as dyne. Okay. So dyne and Newton relation is 10 to the power 5 dyne. So 1 Newton is equal to 10 to the power 5 dyne. Okay. Second, and meter square, we have to convert meter also. So meter into centimeter square. So that is 10 to the power 2 and another 2. 100 centimeter is equal to 1 meter. Okay. So 1 meter is equal to 100 into 100. We have to divide like. So this will get cancelled. So it is nothing but 10. Now see here. That is becomes centimeter square. So dyne second per centimeter square. Dyne second per centimeter square is nothing but Poise. Okay. So 1 Newton per meter square second is nothing but 10 Poise. Or if they will give you Poise, so 1 Poise will be 1 by 10 Newton second per meter square. Be careful about this one. Okay. So whenever they will give you Poise, divide by 10, that will give you Newton second per meter square. This is the conversion of Poise and Newton second per meter square. Very, very important topic and concept in all the numericals, whether it may be in fluid properties or it may be another properties, another topics, everywhere it will be used. So be careful about this one. Okay. Rest thing I will discuss in next class. Thank you.